Hello everyone, I'm Vlad Hale. In this video, I'm going to demonstrate functionality of two Juniper Network products. So we are on JuniperNet Technical Publications web page. The two products that I'm going to talk about are under Network Functions Virtualization, Cloud CPE, and the other product is under Software-Defined Networking. It is called Contrail. So Cloud CPE leverages Contrail, and we are going to see how these two products can be used together in order to provision service end-to-end for the customer. So let us start from the end state. What we have here on the left-hand side, we have a remote site. We have a service that is instantiated. We have central location, and we have this representation of the internet. So what is happening here? We can imagine that the customer is requested that its traffic coming from this remote site needs to be NATed so that it can reach the internet. Instantiation of that service that is going to do the NAT functionality will be done within point of presence within the cloud. So the service is not going to be instantiated at the remote site, but at the central location where the old compute resources are pooled. On the right-hand side, we have several components and entities that will enable this service to be instantiated end-to-end. So let me try to match left and right hand side right now. We have a remote site. That remote site connects to this physical MX device. We also have a cloud, basically, that is comprised of several entities. One of these entities is OpenStack and Contrail, OpenStack being virtual infrastructure manager. SDN component is Juniper Contrail. New application that I just mentioned under Network Functions Virtualization is Cloud CPE solution, or also known as Contrail Service Orchestrator. This set of applications here is hierarchically above OpenStack and Contrail, so its role will be to provide more abstraction so that customers can achieve instantiation and provisioning of service end-to-end in more easy fashion. So CSO is a typical full-blown web application that has its front end and back end. It is comprised of several microservices. All these microservices communicate through REST APIs. Also, it communicates with Virtual Infrastructure Manager and SDN through REST APIs. So let's see what kind of technologies we have involved here. What kind of technologies are at play actually here. So any service provider out there or large enterprise are running some flavor of L3 VPN, which is described in RFC 4364. So there is nothing new here. We are using the same model to seamlessly connect physical world, which is represented by this MX, and virtual world of this cloud. So for the control plane, we are using MPBGP. We are going to exchange labeled IPVPN routes. So there is nothing new here. The BGP session will be established between MX and the Contrail controller. And then these routes will be propagated internally to the entity that is called virtual router that lives in hypervisor of the compute host, which is a forwarding component of Contrail solution. So what we have here is a off-the-shelf x86-64 compute server, basically 64-bit architecture computer or a server. Within that server, which is based at some point of presence, we are going to instantiate a virtual network function. In our case, that will be virtual Juniper firewall called vSRX. That virtual network function is going to provide certain service. In my case, I will be demonstrating an example with NAT service, So this is going to be super simple. So the end goal here is to achieve flow of traffic from remote site through this MX into the virtual world of this vSRX. NAT will be performed on this interface, and then traffic will continue towards the internet. So that is the end goal that we are going to achieve. So several things to pay attention to. So we are using L3 VPN and MPBGP in control plane. Transport mechanisms or data plane is pure IP. So this is very important to stress. The underlay network is required to support only IP. There is no MPLS in the underlay network. So there is no RSVP, no LDP, no MPLS. It's pure IP. Current technology that I'm using here is MPLS over GRE. Other technologies are also transport mechanisms are supported, MPLS over UDP. And if a layer 2 infrastructure needs to be extended, then we use VXLAN. But VXLAN we are not going to mention in this video anymore. At the moment, as of April 2016, Junos does not support MPLS over the UDP. That is coming in one of the next Junos releases. So now I'm using MPLS over GRE technology. This entity here, called virtual router, supports all three means of transportation. So MPLS over GRE, MPLS over UDP, and VXLAN. So let us get started. I'm going to switch between several screens here. I have a number of Python scripts that wrap up REST API calls. So I will later on mention briefly what REST API is. For now, it is just enough to know that all these microservices that we have here communicate with one another through REST API calls. So this is the paradigm of modern software as a service application and service-oriented architecture. So this application is built according to all these modern paradigms that we have. So let us get started. First things first, I have a number of Python scripts, as I said, and we are going to make now this. I'm going to discretely execute these scripts so that we can observe what is happening through different web UIs, in different web UIs of Contrail, OpenStack, and Cloud CPE. So first we are going to create a new project. New project will be called customer 17. I need to allocate two parameters for this new project, route target and the subnet. So what are these parameters? Why they're important? I'm setting the stage here so that vSRX, when it comes online, it will have two interfaces, left and right. I'm setting the stage now for this right-hand side of the diagram, right VRF and its subnet. So vSRX will get its IP address from that subnet, and I'm marrying through route target these two VRFs. So there is nothing new here. Let us check that we have now this project enabled in the dashboard of Horizon. Yes, we can see customer 17. At the moment, this customer 17 does not have any users. So let us add some users to it. I have a number of users predefined, so let us speed up things a bit. So let me check now. Yes, the users are here. These users will become important later when the service needs to be created, designed, and also observed, instantiated. So that is done. The next step is I need to instantiate this virtual network. So what is happening here is microservices are making RESTful API calls to OpenStack and Contrail to instantiate this network. So Heat engine is involved in this. So at the moment, the network is being instantiating. We need this network to be in instantiated state. So still instantiating, so it takes a bit of time. And now the network is instantiated. One more thing that I need to do, I just quickly need for this project to change default security group because it's very restrictive. It doesn't allow security group, it doesn't allow any ingress traffic by default. So I'm just going quickly to enable that. And another thing that I need to do in Contrail is to make this network a shared network. I already have some things predefined here, like management network that I didn't mention so far. So management network, and this is the instantiated network that we have just basically instantiated, customer 17 network. Let me just make it a shared network. And we are done here. So once we have done all this, it's time now to add a remote site. So we are going to add this remote site. I'm going to call that site actually Los Angeles. So and the site is instantiated. So let us quickly go into self-care portal. This is what customer will be able to see when it logs on. So customer 17, one of those users that I have created, are now logging to the customer portal. So we have the skeleton of the connections that the customer will be able to see. So central location and the internet. I'm going to add this remote site. Once again, I'm showing only a very narrow aspect of CSO application. So now we have this remote site, and once we import and design the NAT functionality, we are going to instantiate to bring that network functionality here between LA. Visually, it will be representing that as if it was between the remote side and central location. So let us log on to Network Service Designer. So let us design quickly this new virtual network function. So new request, I'm going to call this simple NAT 17. I'm presented with the function palette. I have different functions that I can choose from. For service chaining purposes, for this application, I'm just going to use a NAT functionality. Also, we could use actually firewall and then chain them together. I'm not showing that in this video. So let us specify some goals, for example, number of sessions and bandwidth, like 200 meg. Why this is important? Because at some point we will have to choose concrete instantiation actually from different vendors of these virtual network functions, and some of them will be able to satisfy or not satisfy these goals. So once we are happy with this, I will quickly create. So I will be using Juniper and here I'm enabling the NAT service. Obviously, if I used firewall, I could have added firewall to the vSRX device. I could have chosen some other vendors virtual network functions, which I'm not at this time. So let me add interfaces, ingress interface, and egress interface. We also have a management interface. We see that both goals are satisfied. So we are happy with the creation of this service. What we need to do quickly to configure so customers 17 not loop back 3 gigabit Ethernet 0. These interfaces are very important in Juniper parlance because every vSRX device, when it comes online, usually it has left and right interface in its simplest form. So that is what we are specifying here. We also need to configure security zone. So that will be left zone, right zone, left to right, set 1, rule 1, not rule name, rule 1, source address. We are going to be very permissive. We are not interested in vSRX functionality. So policy name, policy 1, source zone left, destination zone right, source IP any. So basically I'm enabling for any traffic and any application that this NAT functionality be provided. So save and apply. So this config will become active once vSRX come online. Element management system, which in this case will be Juno's space, will be configuring this device once this device comes online. If we are happy, we can save this and publish. So this is our work done on the network service designer side. What we need to do now, we need to import or attach this to the customer so that customer can see this service, so that service is available for instantiation. I already have a simple NAT function pre-configured, so I'm going to attach this to the customer 17. I'm attaching simple NAT. If I log on now to customer portal and refresh this page, I should see a simple NAT function being present here. So I'm going to select that and I'm dragging and dropping this onto this line. So the service is there, it's still not active. So let us check the config for the last time that we are happy. So I'm going just to put here 17, loopback is okay, DNS left and right interface and apply. And just one more time, I need to check service configuration, left to right, 0, 0, 0, that allowed, that's all fine. So if you can see here, I have a button actually that I can press and instantiate this service. This is how customer would instantiate this service. What I'm going to do, actually, there are some nice logs that we can observe just to see what is happening on the heat side and in NFVO, Network Service Orchestrator side. And once we are happy with that, I'm going to instantiate now this service. So activating, let us see what is happening. So the vSRX now should be coming online, started, create stack, create started, create in progress. We see that here create is in progress. But we are not done here. So what we need to do, I didn't configure the left VRF on MX. So what I'm going to do now is using Python, PyEasy framework, I'm going just to add this VRF. So I already have all the data available. So Python build VRF, use this loopback address, description, routing instance customer 17 left, interface loopback 17, route target, and this all looks good. So let us build this VRF quickly. So this is done. Let's see, show routing instance customer 17 left. Yup, it's there. So let us go quickly back onto to see what is happening. So create complete. Okay, so let's see on OpenStack what is happening. So customer 17, let us see the project. And under instances, we have our vSRX instance that is coming online. If you look at these IP addresses, one is FXP0, the management address. The other one is from the right VRF and one from the left VRF. So our vSRX device obtain all three interfaces will obtain actually those IP addresses. There are a lot of moving parts here, so I'm trying to switch from one to another. Let us concentrate on Juno Space element management system. This is the system that has been just notified that a new device is coming online. This is its management address. And what Juno Space is doing, it's basically probing vSRX device so that it can log into it and configure it. So we are going to monitor this screen to see actually when the vSRX comes up. While this is happening, I will just briefly touch on certain aspect of RESTful APIs that we have that CSO and Contrail are using. So just quickly, I will use this particular space here to try to write. It's not going to be nice. It's probably going to be ugly, but so let me choose pen and here. So what do we have? Every web application, modern web application, has in its backend some kind of database. Operations that we can use that we can do on the database are so-called CRUD. So this is create, read, update, and delete. So this is basically what we have on the database that lives in the background of at the back end of any web application. On the other side, we have HTTP and resources being exposed so that certain verbs from HTTP can act upon those resources. So let me just quickly, perhaps it's not easy to explain actually what I'm having in mind. So we have HTTP protocol that is present everywhere. So, and HTTP has a number of verbs defined. So the most popular ones mostly used are post, get, put, and delete. So these verbs that we see in HTTP, the same verbs, they're married to DB operations like create, read, update, delete. So post, create, get, read, put, update, and delete. So what we have in RESTful APIs, we have certain resources exposed. These resources are basically made of HTTP verbs plus URI. So this is what goes behind HTTP semicolon, then dash slash slash, and then we have certain address. So this is a particular resource that is available. So this is what makes so-called REST paradigm. Representational state transfer, which both of these applications are using to communicate among themselves. So this is the concept that is present in any modern software as a service application that is built with service-oriented architecture model. So let us see actually how that works. So for example, this is a HTTP verb, and this is a resource that is exposed. Always when dealing with this kind of access, I need to obtain a token, so I need to be authenticated against one of the microservices so that it knows who I am and what I can do actually on the application. And for example, using curl as a tool, I can see, for example, what this resource is. I can read, for example, in this particular case, I'm using verb get, and I'm using this resource that lives on this application, which is exposed to me so that I can read. If I want to use something more fancy, then I would find a client with nice visual user interface. I would get authenticated. So for authentication, I'm using post verb. This is a microservice that will provide me with a token. I'm submitting certain parameters like my password, admin, who am I, so that token will be issued. And here actually in the header, what I see, I obtain a token. We always need to think about this token when we are dealing with that stuff. And for example, let me see this resource. So this, I'm using get to read, for example, particular resource. I'm just going to paste and here we see that I'm, for example, reading about CSAS pop. That pop is test pop that where I'm instantiating these examples. So this is basically what REST API is about. It's the whole science behind it, but all web applications are using internally these kind of REST API requests so that they can act upon certain resources that are exposed to them, and at the back end is always some kind of database, and that all gets translated into this CRUD model. So let us see where we are with our instantiation. We can see that vSRX device is running. Let's check on Junospace. So we see that Junospace have logged in into device, at least it recognized device, it's done something on it. What we should expect it to do is to provision with the configuration that we've done at Network Service Designer part of this video. So let me now log on to CSO vSRX. Show system commits. So I see actually that configuration have been committed by Netcom protocol, by Junospace device and using Netcom protocol. Show configuration, security zones. So this is security zone left and right. So that is fine. So, and I can see actually the traffic is already going. I just want to see run show route table. So what I can see, I see the default route. We see that it is available through GRE and other routes that are present in this customer 17 left routing instance. So if we ping so we are able to ping the Google's public DNS server, and just to be on the safe side, let us check show security flow session not. So indeed, I'm pinging from the loopback address, Juniper public, and the traffic gets translated into the right vSRX interface. So one more time, what we have achieved here is this. We have steered the traffic through vSRX to provide NAT functionality on this interface. So this is where NAT functionality is happening. So the traffic is steered from the physical into the virtual world, back to physical world, and to reach the internet. So I hope this is a useful stuff for anybody out there who is watching the video. I thank you all, and also stay tuned because Cloud CPE is just in its first release. More stuff is coming in the next few months, and we hopefully will be doing more videos on this subject. So this was 101 on Contrail and Cloud CPE solution. Thank you. Bye bye.